All right, so today we're talking about the triangle proportionality theorem. So what's that all about? So let's say we have a triangle drawn here, like so, and let's say we're trying to draw some line in this triangle that's parallel to another line. So if we knew that we had right here was a parallel line to the base, this tells us some things about this triangle. Now, what does it tell us? It tells us that these two sides are proportional to one another. Now, what that means is if I had different letters to represent each segment of these sides, say if I had A, B, C, and D, if these two sides are proportional to one another, that means we could set up a ratio such that A over B is equal to C over D. So we set up two ratios. We got A over B and C over D. And if they're equal to one another, they are proportional. The reason for this is because we have this parallel line to these two sides. If we wanted to go into more detail with that, the reason that this works is because of similar triangles with these two overlapping triangles. Now, where this is useful, where we'll use this mostly for this class, is when we have three of these sides, we're looking for the fourth side, we can find that using this proportion. Going the other way, the converse of this is also true. So if I knew, let's draw a new triangle here. Let's say if I had this triangle and I had a line going across right here and they look like they're parallel, but we're not exactly sure. If we have the sides, the information about the sides, say if I had 3 over 6, and then say if I had, I don't know, we'll say 1 over 2. If I had these two sides right here on the left side and the bottom side, we can then figure out if they are proportional. That'll tell me whether or not these two lines are parallel to one another. So if I set up my proportion, the first one I'd say 1 over 2, which is simplified to be 0.5 or 1/2. And then we'd have 3 over 6, which would also simplify to be 0.5. So we see, since both of these have the same ratio, that tells me these two lines are parallel to one another. So that, in a nutshell, is the triangle proportionality theorem. Let's go ahead and look at some examples where we kind of use this to solve this. Here's kind of essentially what I just said in more, academic terminology, if you will. So if you want to look at that, that's basically what I was just going through with this triangle over here. Let's look at some examples. I got find the missing links at each of the figures. So say if I had 3 over 4 for Vy, and I got Vx here. I'm missing this Vw is what I'm trying to find, so I'll put an X right there. So I know these are two parallel lines. I can set up a proportion to solve for this. I would say, in this case, 3 over 4. Again, this 3 from here, this 4 from here would be equal to x over 8. Now we can solve this problem by cross multiplication. So I would say 4 times x gives me 4x, 3 times 8 gives me 24. And then we just need to get x by itself. So we do the opposite multiplication here. We divide by 4. We end up getting x equals 6. So that tells me VW is 6 units long. All right, looking at number 2, HF is what I'm looking for here. So I'll call that x. So I'm trying to find. I would do the same thing. I know these are two parallel lines, so I can assume this is going to be proportional. So I can say x over 4. I'm getting this x from here, and this 4 from here would be equal to 2 over 5. Actually, the other way around would be equal to 5 over 2, kind of being consistent here with the start from the bottom, working up. So then I can cross multiply, it'd be 20, and then 2 times x would be 2x. And then I got to divide by 2, I get x would be equal to 10. So HF is 10 right there. All right, and then looking the other way, so this is talking about that converse I was talking about. If you have the 4 side lengths and you want to prove, okay, are these two lines parallel, we can prove this if we have two ratios that are proportional to one another. So in this case is ZW, so ZW would be right here, is ZW parallel to YX. Now it looks like it is, but let's make sure when we find the proportions here, because it might not be drawn to scale. So I'll say, in this case, 3/7, 3/7. It's got to be equal to 5/8. All right, so I'm going to grab a calculator around here somewhere. I'm edged on my computer, but 3/7. Those two aren't going to be equal to each other. I don't even need a calculator if I look at it. Those aren't going to be equal to each other. 3/7 and 5/8. So I can assume that these are not parallel to one another because they don't have the same ratio. So we'd say no ZY, or excuse me, ZW is not parallel to YX because the ratios are not proportional. All right, and we'll stop there.